Conference. In this training, I want to take you through some of the major topics on data visualization that was done for Ferma staff. So we started by introducing what Power BI is. So that's my name and my details are there. I remember under the introduction for Power BI, I said that Power BI has these four sections. The first one is your data, getting your data. So how do you want to capture this data? How do you want to clean up this data? How do you want to get it ready for analysis? That's what happened at this stage. Once you've gotten your data, the next thing will be to transform this data. This is where you can use Power Query language to further work on the query, on the data to make it something presentable so that you will have realized the kind of result you're looking for. So once you're through with this, then you now load it to the report view environment. So it is at the report view environment that you can view and format your visuals before you can now save, share, and publish this data. So, but before we go on, let's really understand what data is. So data analytics is a process of examining data sets to draw conclusions about the information they contain. So once these data are examined, we should already have in mind what we hope to achieve. So the four types of data analytics are descriptive, diagnostics, predictive, and prescriptive. While the descriptive talks about what happened to the data, the diagnostics talks about why did it happen. The predictive talk about what might happen, and prescriptive talk about what should we do. So once we analyze our data and draw insight, then we'll be able to answer all or some of these questions. So, and we can further represent that data in form of what we call data visualization, which is the representation of information in charts or graph or dashboard. The purpose is to simplify complex data for decision making, and this can be done using tools like Power BI, Tableau, Excel, Python, and the rest of them. So in the class, we had two data sets that we got. The first one is the road maintenance record. So we can see from here it has serial number, it has states, different states in the southern and the northern part of Nigeria. Then it has road ID. So these are represented by the numbers you're seeing. The road names have been changed to the numbers you're seeing here. And of course, the cost of repairs. So this cost of repairs again has been reduced and formatted to the format we're using here. So we're not using the real figures. The duration of repairs, the maintenance type, whether it was pothole, cracks, uh, resurfacing, whatever it was, they are all listed here, and of course the repair date. So this forms the basic fields that we have on the road maintenance environment. Then of course on the far right here we also have another table which is called the weather record, and this of course has information about weather in those regions, and the months are shown here. So the frequency of rainfall and the amount of rainfall and the roads that were destroyed, and of course the accidents that were reported. So these two tables forms what we're going to use for our work. But before we started using this table, we did what is called data cleansing. That is, refining this data in such a way that it will be presentable. So the first thing we did here was to format this table in appropriate format. For example, if you look at the way the date is appearing here, I could say, oh, I don't want the time that is appearing as 00 dot colon and the rest of them. So I just want it to come out with appropriate date. So what I'll do is I'm going to select the entire column and tell it to do the same thing. So I'll do this, right click again, then I'll click on format cell, then I'll choose date, and I'll tell you this is how I want my dates to appear, and I'll click OK. So all the dates have been formatted appropriately to the right format that I want. So that's how I got this. Then another thing we also did was to check for repetition. So again, if you look at this table, this is the original table that we got. So don't forget this section comes under data cleansing. This is a possibility of two roads having the same activity being repeated. So let's just take the whole of this. Let's take the whole of this, and so I've repeated the same thing here. Then the same thing here too. I'm going to take the whole of this, the whole of this, the whole of this. I'm going to take the whole of this and repeat it. I'm taking the whole of this, and I want to repeat it here. So I'm taking the whole of it. So I want the system to tell me all the rows that have duplicate values. So I'll highlight on the entire table. And when I highlight on the entire table, I'll go to conditional formatting. Then here, I'll say highlight sales rules. I have duplicate values. Under duplicate values, I can choose the kind of color. So I'm on duplicate here. Kind of colors I want to use to fill them up. So I want to fill it up with green, fill with dark green text. So I'll click OK. So all the areas that has that green fill means that they are repeated somewhere. So you can see these two are boldly repeated. So that draws my attention to it. So I can always effect the correction to get that out. That's how you do your conditional formatting. Then of course you can do sorting. Let's look at the case for sorting. If you look at this table, you find that Lagos is appearing here, but we also have Lagos in the last section here. So they are mixed up. So how do we sort this out? How do we sort this entire table? So one way to do this is to highlight on the entire table. Then I'll right click on it and I'll go around where you have sort. So under sorting, I can tell it to sort. So I have sort oldest to newest, sort newest to oldest, sort, put selected cell on top of color on top. So I also have option to use custom sort. So here under custom sort, I will say, okay, let's sort state from A to Z. Then I'll click OK. So we'll see what just happened. By sorting state A to Z, so all the states now are arranged in alphabetical order and the format and they follow a particular order. So that's another way to get your data out. So once we are through with this data, then we can now take it for visualization. Based on what we've done, this shows how our final road maintenance record will be. So you can see what we've done here is that the date format is appearing appropriately, and also the states have been sorted in alphabetical order. Though even though the serial numbers are not the same, but we can easily correct that. So if I type 1 and 2 here, I can highlight on this and drag down. So when I drag down, the system will automatically rearrange that number the way it's supposed to be. Then the repeated values are being removed. So this is clean and ready to go for visualization. The same thing too with the weather report. So everything is looking nice here. So we are good to go. There's no repetition, and we can get working with this. So now we're going to do something. So starting with this weather report, we can still do further analysis on this. Look at the weather. So we have under the weather report, we have serial number, state, region, month, rainfall, frequency. Then we also have the road destroyed and the accident. So we want to know, because of the amount that is spent on road repairs, does the rainfall volume and of course the frequency has anything to do with the number of roads that are destroyed in each of the states? So that's a question. So to be able to answer that question, we're going to use what is called regression analysis. It's an AI tool that we'll find in Excel that will enable us to get it done. So let's go there and get the answers to that. So again, this is our weather table. So we're going to take this for regression analysis. So I'll click here and I'll go down to area demonstrated. So I picked those 3 columns. So I have the road destroyed, which is our output. In this case, it is the Y variable or dependent variable, while the frequency and the volume of rainfall will now become the X variables or the independent variable. So we want to see whether these two has anything to do with this. Then if it does, then we'll now look at the region in the country that has highest amount of rainfall, and we now check the impact on the roads there then that will help us to really understand the kind of texture we should use when we are building our road. So to answer this question, again, we're going to use regression analysis to get this done. So let's get started. So to use regression analysis, the first thing we'll need to do will be to ensure that we have data analytics installed on our Excel. So if you go to data, then you see data analysis. If you don't see data analysis, then what you do is to go to file, then you click on options. And when you click on options, you click on add-ins. And here you have manage add-ins. So you click there, make sure that Excel add-ins is showing, click OK, and make sure that an analysis tool pack is checked. Once this is checked, you click OK, and that will automatically bring out data analysis here. So with this data analysis, it's now easier for us to work on this. So now, how are we going to use regression analysis to get this question done? So I'm going to click on data analysis. From there, I'll look down and look for regression analysis. So I'll click this. So the system is asking me, what is your Y variable here? Don't forget our Y variable is the road destroyed, which is the output. So I will click here and I'll select the whole of this from beginning to the end. Then what is our X variable? That is our input variable, so or independent variable. I'll just highlight on the two of them and I select this. I'll check label, then I'll click on output range. Same thing, where do you want to put the output? So I'll click here first, then I'll now click here. Then I'm going to include the residual. That is, if there is a difference between the actual prediction, the actual from the predicted values, then that difference is what will be classified on a table called residuals. So I'll choose where that residual will be and I'll click OK. Immediately I click OK, the system works out all this and explain, tells me what happened. So I'm going to explain this line by line. You see, don't forget, the reason why we're here is to find out whether this independent variable has anything to do with this. So we don't just assume, we use the Excel formula to get that done. Let's explain that formula line by line. Before we go further, let me just explain what regression analysis is. It's a set of statistical methods used to estimate relationship between dependent variable, in this case the road destroyed, with one or two independent variables. It's a reliable method of identifying which variables have impact on a topic of interest. The process of performing a regression allows you to confidently determine which factors matter most, which factors can be ignored, and how these factors influence each other. In the example, the dependent variable is the road destroyed, while the independent variables are the frequency and rainfall volume. So here, so this is the first table that we got, which is the regression analysis. So here you watch out for this value for R squared. So R squared is equal to 0.979, which is about 97%. So this shows that 97% of the variable road destroyed is explained by the two independent. So this is good and it's closer to 1. So this is quite good. This value, if it is less than 0.5, then that means that those two independent variables, the rain and the frequency of rain, does not have anything to do with the number of roads. But this tells us that this is really available and is related to it. Then we now move to the next section, which is called ANOVA. ANOVA means analysis of variable. So here what you look out for is significant F. So if this value, to check if your result is reliable, statistically significant, look at significant F. So you can see this is our value. If you convert this is what you have. If it's less than 0.05, then you are probably okay. But if it's greater than anything 0.05, then it's better to stop using those independent variables. So that also confirms that what we have. Then this section now basically gives us the formula to use. This formula we can now use for our prediction. So this is the section that we're now going to derive this formula. So it is this formula you're seeing here is derived from here. And because it's derived from here, so you can see here that rain destroyed is equal to minus 289 plus frequency times 1.0 plus rainfall times this. So that means if we substitute all the values for frequency that we have on our original table and substitute the values for rainfall, then we should be able to have the amount of road destroyed, which similar to what is shown on the table there. So again, so this is what we got. This is what the original table that was given to us. Is that it? Okay, no. This is so if you do a calculation, if you substitute the values that we got for frequency and the values that we got for rainfall into this equation, this is the value that you have. So you can see the predicted value for road destroyed is 10.42, but what was predicted here is 10, quite close. So you substitute and you have all this. So once you bring it together and you find the residual, you can see that it's very close. It's relatively very close. The difference is not much. So this will give us a linear graph. So that's basically how we can use. So with this now, we can use this to predict what will happen. So if somebody now asks us, okay, what happens if the volume of rainfall is 500 and the frequency is 60? So all what I need to do is substitute it here. Then I can now predict and tell you the number of roads that will be destroyed, all things being equal. So that's what we got here. So having this now, we now finally fine-tune our table. So under the road maintenance, we still have the same field that we got after cleansing. Then under the weather, we now added something. So we had our state, serial number, state, region, month, frequency. So we now added predicted bad roads and actual bad roads. So I just added those two columns. So now that's what we're going to now move to our Power BI for visualization. So it is these two tables that we're going to use for our visualization. So I'll just take this to Power BI and you see how this is going to work. The first thing is I'm going to save this file again where I know I can find it. So I click on Save as Desktop. So this becomes our data set. So I'll call it data set Ferma. So I'm saving this on the desktop. So I will show you how to take this to Power BI. So I will look out for these two files, PI maintenance and PI weather. So I'll click on my Power BI to open it. So when you open to Power BI for the first time, this is what you're going to find. So here is asking us select a data source or start with a blank report. So I'll click on Excel. So you can also bring your data from SQL and other sources. So I'll tell it, look, I want to import this from Excel. So just click there. So it's asking us here to select where the file is. So I'll click on my desktop. Then I'll click on dataset Ferma. The system is connecting to the dataset. So when it connects, this is what you'll find. So this is coming from that Excel document that we have. I pick on the two sheets that I want to work with. So I'm picking PI maintenance, then I'm also picking PI weather. So that's the two files that we're going to work with. So I won't just load it straight to the report view and start working. The table is showing there, but I will just do a transformation. So I click on transform data. The two files are loaded here. We have our data here, PI maintenance and PI weather. This is a Power Query environment. The language that is used here is M. So now I'm going to click on each of them and further work on the table. So here looking at the PI weather, these are the options I have. I have serial number here. So I don't want this column for serial number. So I can right click here and set the remove. Now every command you do under this applied steps is shown here. You've just noticed that I've just deleted a column for serial number. So if I click on it and say delete this, what happens? That returns back. So you can always return back to what the last action you took by just deleting that action. So I'm going to delete this again. So I'll tell it to remove, and of course it's telling me that you've removed an item. So if I want to reverse it back, I'll right click and take that out, or just click here to take it out. So I have state, I have region, I have month, I have frequency, I have rainfall. Then I also have road destroyed, I have accident reported. Then again, I have predicted roads, bad roads. So here I can just double click on this and make it one word, predicted or predicted road. Then actual bad roads, I can just also make it one word. So that's what I've modified for PI weather. Then if I click on PI maintenance, you see here that my column is on the first row while something else is going here as a column. So what do? I will highlight on the second column, then I will move right up here. You see where you have use first row as header. So I'll just click there. So what happens is that it takes that thing off and brings this one as a header. So from here, I can right click here and say remove this. I don't need serial number. So I have state, I have road ID, I have road name, road cost, duration, maintenance type. Then of course I have my repair date. So this is what I want. This is what I want. So these are my two tables. I'm now going to load. I can do other things here. So like I said, the language that is used here is M, and I can do other things here. So I can load the two of them at the same time by just clicking on close and apply, and all will be loaded back to the report view environment. Or I could specifically say right click on the one I don't want, and I will tell it to either disable load. This is enable load. So if I click on this, it means that I've disabled load. So if once I'm loading my data set to the Power BI report view environment, then this will not be added. So but I want the two loaded, so I just click on it. So the two are active, so I'll go to close, and I can now bring that over here. So the system is loading my two it's telling me here that the 25 rows for PM maintenance and 15 rows for PI weather has been done successfully, shown by the mark. Then we'll have to wait for this to go out so that it can appear under the data section. Okay, so our two data files have been loaded here on the data section. So let's just take you through this environment. This is the ribbon. If you click on any of these menu items, you see their commands under them. Then Power BI has this number of views. So this section we're looking at here is called the report view. It's at this report view that you can view visuals with your data. Then we also have visualization. This is where you can pick up any of the graphical tools here to represent your data. This is the data section that shows the data sets that you have. Then what's under here, we have the table view. So the table view will show you the tables, the complete table details for each of the data sources that you have. For example, under maintenance, it's going to load, if you wait a little, it's going to load the content of this PI maintenance. So it's loading. Then under PI weather, this will also load the content of PI weather. So it shows you the two files that you have there. Then under model view, is at the model view that you can relate these tables together, create a relationship. For example, we have PI weather and we also have maintenance. You could create a handshake between the two of them by looking at two columns that are similar that can relate to this. So if you look at this carefully, you can see that we have state here and we have state here. So we can use these two to create a relationship between them, a handshake. In that way, so you can query across to look for anything you're finding. So I'm going to do that here. So, and this data, this model view environment uses a language which is called DAX. DAX means Data Analysis Express. So I'm going to create a relationship between these two tables. So I'll click on Manage Relationship. So the system is asking me to add new table. So I click on New Table. And here I will select the first table, PI Maintenance. Then I'll select the second table, PI Weather. So what the system is already telling me, look, I've looked at these fields and I found that the two states here can be related to this. So do you want that? I'll say okay. So you will create the relationship between those two tables. And so that means that when I'm querying, I can query across those tables. So I'll wait for that to be completed. So the system has created this relationship between the tables, and I can click on close, so you can see the handshake there. So I can return back now. So what I'm going to do now is to spend time here to create different visualization for these two tables. So starting with the PI weather, don't forget, we want to know, if you remember what we did under regressional analysis, we want to know whether the dependent variable, in this case, the road destroyed, is directly related to the two independent variables, which was the volume of rainfall and the frequency of rainfall. So we're going to simulate that on the system, and we'll create a linear graph and see how close the prediction was and the data was to get that done. So to do that, so I'm at the PI weather table here. So the table, the graph I'm going to use is scattered chart. The scatter chart will now show me, give me an idea. It will create a linear graph, then a line. Then it will now show me some of the figures that falls on the line, meaning that it was rightly predicted, and the ones that were over predicted, ones that are above the linear line, and the other ones that are below the linear line. So we're going to use this to get that done. So what are the fields that I'm going to use here? I will choose, so I have predicted bad road and the actual bad roads. Those are the two fields that I'm going to use. So what I'm going to do will be to drag these two. I'm dragging the predicted bad road. So let's drag this over here. And I'm also going to drag the actual bad road here. So those are the two fields that I want to add here. Let's do that again. So I'm going to drag, so the two values I'm going to work with will be the actual bad road. You can see this is summation. Then I'm going to work with the predicted bad road. I'll put the two of them together under values, so they are all here. Then for the x-axis, I want the actual bad roads to fall in there. Then for the predicted, I want the predicted bad roads to go to the y-axis. So let me just show you what I've done. Under values, I've said, okay, these are the two values I'm going to work with. And on the x-axis, I've said, okay, I want the actual bad rows to fall here, and the y-axis, some of the predicted bad rows. So the system has plotted the graph here for me. So you can see it's almost a straight linear graph. So I'm going to draw a straight line here and see those points that were correctly predicted, those that were over-predicted, over-estimated, and those that were underestimated. So I'm going to create a linear graph here. So how do I do that? So I'll move from here to here. So this section means add further analysis. So I'll click there. Then I'll click on the trending line. On this trending line, I'll switch it on. Immediately I switch on, the system now draws this line automatically. And of course, I can change this from a dotted line to a dark line. Make this a bit bigger, to a dark line. So you can see how close this is. So what have we just done here? So we've seen that a lot of some of these values fall directly on the line. All these ones were overestimated, and this, so it's very, very close. So this again proves that the volume of rainfall and the frequency of rainfall has something to do with the number of roads that are destroyed. So we can now look at the region. Where is this happening the most, and can we put in more money there in order to and improve the quality of roads in those regions that have heavy rainfall? So the graph is already explaining that to us. So having done this, so I'm going to now show you other graphs based on other variables that we're going to use. Before I do that, I'm going to change this graph to the cluster column chart. So this will automatically change the shape of this graph. So you can now see how close is it predicted with the actual value. So you can see this is quite close, very close, very close. So that shows that the formula we got from Excel is not really far from the actual result, and from there we can rely on that formula to get things done. Let's see more graphs. So I'm going to bring in, under PI maintenance, I'm going to bring the state to the x-axis. Then I'm going to bring the sum of repair costs to the y-axis. Then I'm also going to bring the duration of repairs to the legend. So once you do that, this is the graph you have. So let's stretch this and see what is there. So this is what we have. So we can now change this to So this is the graph that we have showing the different states. You can zoom this to see more. So if you take your cursor around here, the system tells you what. So you can see all the roads in Sokoto, and here it's telling us that it will give you a summary that for 5 days was spent here. So I can even still add the road ID for better explanation. So I will just come here and add the road ID so that we can know see which road, what duration, what amount was spent on that. So what I've just done here on the x-axis, what I have is a state. On the y-axis, I have sum of repair cost. Then on the legend, I have repair duration days. So if you take your cursor around here, the system gives you that summary. So you can see here that the highest amount was spent in Kano on road construction. Even though our table did not specifically show how long the kilometers, the length of road was, but the graph tells you that. Then, of course, if you want to add something like the road ID, so that we'll know the specific road. For example, if I take this here, it only shows me 3 variables: the state, the repair duration, and the sum. So, which particular road? The road ID will tell us that. So, we click here and we return back here. So we have another column here which is called the tooltip. So under these tooltips, I can drag my road ID there. So once I drag it there, the system will now add it as a foot fill, and that is now going to tell me what it is. For example, now this is telling me that the road ID here is 1 in Enugu, and it's showing it as count. So if you don't want it as count, so I'm going to take that out. So I'll go to road ID and I will change the format of that road ID. So instead of using road ID, I would prefer to use road on my tooltips. So immediately I add this, I think I've gotten what I'm looking for. So with this now, the graph better represents what I'm talking about now. So if I return back here, I can take my cursor here and the system gives me a brilliant summary. So from here, you can see that the state is Sokoto State and the repair duration was 5 and the sum of repair was 14,678 Naira. And of course, the road name is Road 21. The second one is Road 25. Third one is Road 23. So while we're looking at the cost of repairs, the road details based on the ID number can tell us more about the kilometers and of course the state of those roads. So this is one graph that we can use to see the cost of our repairs. Then I'm going to bring in variables from the two graphs, the two data set that we have, the PI maintenance and the weather. So we want to see the effect of weather on the road, the bad roads in the states. So I'm going to click on, I'm going to create a new graph for this purpose. So I'll still click on cluster column chart. So here under PI maintenance, I'm picking states. I'm picking states for that because there's a handshake, so I can pick values across. Then in each of these, so under my y-axis, I want to pick the actual bad routes, the sum of the actual bad routes in those states. So you see the graph is coming up, the sum of the actual bad routes in those states. Then under legend, I can also add something about the rainfall, the rainfall state in those states. Then I can also add something about, let's look at what I've just done. So this is what I've just done. So the system is telling us information about the actual bad roads, the amount of rainfall. Then of course we can even add something on the frequency of rainfall. So we can add the frequency of rainfall under the tooltip. So the system will now tell us more. So this is what we have. So you can see from this graph that we had more rainfall in River State, Lagos, the southern part of the country, while we have few in northern part. So if you take your cursor close to it, the system now gives you a breakdown of the summary. So in River State, when the rainfall was 250, the volume was 250, the frequency was 13, and the actual bad road was 15. So let's see what happened in Sokoto. So you can see frequency 4, actual bad road 2, rainfall was 40, and this was in Sokoto. So you go around, the system will tell you more. So we can change this graph to any other type of shape that we want. I've just picked the clustered bar chart. I was working with this. So let's also look at the stacked column chart. The system will represent all this in different file format for you to see. So that's basically how this is done. Then the next thing I'm going to do will also be to change this to a map. Let's show the amount of bat rows in different states in the country. So I'm going to simulate that here using this environment. Before you use map to simulate your the visuals for your data set, it's important for you to ensure that map and map fields are enabled. So I will go to start, then I will click on options and settings, then I click on options. So when it opens here, I'll click on security, then I'll look down to where I have map and field map visuals. So click there, be sure it's, and then you click OK. So that's the first step. Then the second step is, because we've established a relationship between these two data sets, I can query them through. So I can query through to bring out my map. So I will click on map. So here I will pick state. So for location, I will bring state into location. Then I can also bring the cost of repairs. Repair cost under legend. Then finally, I can add the bad roads, actual bad roads to my tooltips. Then for the bubble size, I want something to increase the size of the bubble, so I could just bring in something like frequency of rainfall. So this is how my map is coming out now. Gradually building. It's important to ensure that you are connected online. You're connected online and the system will simulate that for you. So you can see the map of Nigeria, you can see the different states. So if you take your cursor around, the system shows you the summary of what happens in each of those states. If the map is not appearing after activation, make sure that on your Windows setting, you set your region to United States. So once that is done, then this will show. So that's what we did. Once this is done, then we can of course publish this and share it. But on a web platform, we can also take all this online. But in this case, we'll be working with PHP and MySQL. This application will enable us to build our site and of course use SQL codes to configure our data set. So now what you're seeing here is a dynamic website that has a report about a backend database that is running. So just like I said, any changes that is made at the backend will automatically reflect it. So what do we have here? We have a pie chart that shows different states with different values. We have the map of Nigeria that is showing the spatial distribution of cases. We also have a histogram that is showing different cases. Then we have all the summarized values here. None of this is static. Then we have a dashboard that shows values here. So something like this too can be implemented for Ferma. So how do you get to the back end here? In this particular website, you click here. I'm going to show you how that is done. Then from here, I'm going to log in. So I will just click enter. So the system will take me to the back end. So at the back end, there's a summary of activities here. And from there, I could now move straight to the forms. And of course, I can also move to the reports. So it is what we fill on this form that appears on the report. And from the reporting environment, those values are now are analyzed and they all appear here on the front end as the summarized data that we are seeing here. So this is something we can do for Ferma. Thank you for listening.